Hi everybody. Before we get to this week's tech tips, I just wanted to take a moment to make sure that everybody understands the expectations of the parts. Miss B and I have tried to make comments and respond to as many of you as we can regarding your submissions. Those of you that did well either were given a note saying that they looked good, or perhaps we just didn't reply at all. For those of you guys that did receive a comment from us, please take those into consideration going into this week. Please make those corrections before you go into this week's assignment, which is creating the DWG files. You don't want to get to the end of this week and realize that you have to kind of redo the whole thing. So what can you check to make sure that you're good going forward with this week? The first thing is that you should have 5 unique parts, bins, trays, whatever you want to call them. They are containers that are holding your desk items. And when you guys create these containers, they need to be designed to house certain items. So whether it's a little bowl for paper clips or a tray for 8.5 by 11 paper, whatever it may be, it has to be designed specifically to hold or house something. They should not be the same part 4, 5, 6 times. Okay, we had a lot of people that were making, rectangles, but the rectangle box shape was just different heights. That's not exactly what we are asking you to do. There is a creativity element to the design process, and we want to make sure that you're capitalizing on that. Your 6th part should be your base. So there's going to be 6 links that you're going to have to submit, or really you're creating 6 things. 5 of those are going to be your bins, compartments, trays, whatever you want to call them. And then your 6th item is going to be the base, in which all of the trays and bins are going to somehow attach to and or be connected to fit on in some way. And when I show you my example this week, again, hopefully that kind of solidifies your understanding of what we're asking you for. All right, the base should also have some kind of raised edge or indentation or area that is going to house where that bin will go. I should be able to look at your bin, I should be able to look at your base and know where your 5 parts are going to go. So if you're making a tray, there should be a slot for the tray to go in. If you have a circular container that's going to hold pens and pencils, I should see a raised circular area on your base. The other thing you want to think about is color. And the only reason we bring this up is because we want to make sure that, again, that you're designing this to be from a creative aspect. We also want to make sure that you understand how to use the tools that we're asking you to use. So your parts need to be a color. They can be different colors. You can have a couple the same, but make it look nice. Make it look as if you were selling this, somebody would want to purchase it. The only thing we're going to ask is that you not use black, because using black on the computer screen, it's a little disorienting, and trying for me and Miss B to kind of look at it, it's a little hard on the eyes. So as long as you guys are changing the color and you do not leave it the default OnShape blue that the part comes in, you should be fine. But yes, you do need to change the color of all 6 pieces. You need to also define and label your compartments. A lot of you are submitting it as either bin 1, bin 2, bin 3, whatever it may be. You also need to state what it's going to hold. So if you're labeling, and yes, you need to rename your files, what is going to house, or what's going to sit in those things. Also, check the size of your parts. Okay? Be sure that you're dimensioning your bins appropriately. This week, when you're making your DWG files and you're putting the dimensions on the drawings, you're going to be able to see, did you make this part correctly? Is it to size? So please double check your dimensions. And again, I'm just going to reiterate renaming your part file. So going forward, if you have to go back and change the part file in your 3D model to reflect what the bin is, please do that. Once you've submitted or once you meet all this criteria, you can go on to this week's assignment. Again, this is just used as a kind of a Monday morning checkpoint before you get into the DWGs to make sure that everything that needs to be done is done. And if you need any clarification, please ask Ms. B or myself before going into the drawings this week. Okay. But if you're all set to go and you have a good set of ideas and you're ready to make the DWG files, let's go and do that. Hi, everybody. So this week we are going to create our drawing files for each of the 6 parts that you made from last week. I just wanted to guide you through a couple items before we get to the actual creation of the DWG. And that one has to do with how to rename your file. So on your main screen here, if you go to the item you want to rename, so if you remember last week I made this purple box, I'm going to right click here and I can rename the document. And from here you can rename it. Remember, we want it gauged and specifically to whatever it's going to hold. So please make sure you adjust that so that we don't have bin 1, bin 2, bin 3, bin 4 going into this week. The other thing I wanted to show just briefly again is the base. So if you notice kind of on my preview here, you can even see the raised edges. And let me just bring up my assembly here. You guys do not have to do an assembly this week. That will be next week's assignment. But I just wanted to give you, again, a sneak peek of how the parts and the bins are supposed to be going together here. So notice my base and I have these raised edges here. So if you take a look, there would be a spot for each of my bins that I'm going to put there. Your base needs to have this. You cannot just have a blank rectangular surface that you're going to put stuff on. You need to have some kind of allocation as to where stuff is going to go. All right, so now that those two things are out of the way, let's take a look at how to make a drawing file. Some of you may already know how to do this, but in case you don't, it's very similar to how we did it in Inventor. You're going to open up the part that you want to make the drawing for. And then down here in the lower left-hand corner, there's a little plus symbol, and you're going to want to create drawing. Now, when you click on that, you probably won't have, you might have maybe this one as your template. So what we want to do is you want to go up to this OnShape, and that's going to give you all the templates that OnShape has to offer. So we want this to be an ANSI size A, because the size A sheet is 8.5 by 11, and we want this to be in inches. And we click OK. All right, now when it brings it up, it's going to bring up our template, and it's going to ask us if this is the part that we want, which it is. So we're going to click on that. And just like an Inventor, it pulls in what orientation we want. Now, this is going to obviously be different for each bin you made. It's going to vary how you built your part as to what comes up as the quote-unquote front view. You may have to change what that front view looks like, what that orientation looks like. So every part is going to be a little bit different. This may take you a little bit of time. My recommendation, if you're watching this video on Monday, is to either try it Monday or Tuesday to get a feel for it, see how long it takes you to create a drawing and dimension it before you get to Friday afternoon and you're trying to scramble and do 6 of these Friday night. A good self-pace would probably be 1 a day. If you want to get it all done, Monday, Tuesday, and not have to do work the rest of the week, that would be great too. But again, I highly suggest that you guys do not wait until Friday night to do this. So here, I'm just going to plop this in just so you can kind of see what I'm looking at. And if I click in there, it gives me kind of an overhead view. And just like Inventor, if I click and drag my cursor, I'm going to get my top view. And I can click and drag over here and I can get a side view. And if I click and drag over here, I get an ISO. Now you're going to obviously notice that the parts are too big. They don't fit on the paper. In order to scale it down, right, what you're going to need to do is over here on the left-hand side, there's a little Sheets tab that shows you, similar to your browser in Inventor, everything that you just did. If I right-click on Sheet where it says Properties, okay, it's going to ask you for the scale size. Right now, this is a 2:1, and I can change this manually, or there is a drop down. So if some of you have some of the bigger parts that might be the base or something different, you can adjust the scale accordingly. But I would imagine that most of your bins fit on an 8.5 by 11 sheet. And once I do that, now I can drag parts in, and I'm looking at my orientation of all of the pieces. Right, I would definitely make some changes here because this, as my front view, it's okay. This is my top view is okay. Probably with most of your bins, you're going to want a section view. Right, you're going to want to be able to cut the thing in half so that you can see the thickness, especially since you guys all were supposed to do a shell feature. You should be able to see the thickness of that shell and what the cutout of that area looks like. So let me show you guys what that piece would look like. So I'm just going to delete this because more often than not, I would probably want, this could be my front view. I could call this my front view. I might want to rotate this. There's a couple different ways I can do this. If I leave it up here as my top view and I make what would be my front area view here, the section view, and we've done that on some previous examples, that would be fine too. It's probably going to give you a little bit more detail. So up here on the top, there's kind of this disjointed arrow, and it's called section view. And it's going to ask you, do you want a vertical line or do you want a horizontal line? So how do you want to cut this? Well, I want to cut this across in half going this way. So I'm going to change this to horizontal. And if I zoom in here, you're going to notice that I can pick up and highlight corners of the shape. And when I do that, I just need to click one time and it's going to give me a set of arrows based on how I want to draw this. And I'm just going to kind of click and drag and pull myself down here. So it's giving me that arrow section like we've done before, and it's given me my section view. So again, a section view where I have the diagonal lines here, this would be solid material. That's what I'm cutting through. And this negative white space here would be the inside cavity of my bin. On the side view, right, you can notice that I've done some chamfering and how that would look. Okay. So to dimension something, remember you guys want to start with the overall dimensions first, length, width, height, and work your way inward. So some of you, depending on how complex you made your objects, might have a little bit more dimensioning than some people did, made some simpler designs. To dimension something, up at the top here, the diagonal arrow section is where you're going to dimension. If you click the arrow next to it, brings down this nice little pull box of all the different kinds of dimensions you can use. Some of these are going to be really, really useful and I think are more helpful than some of the Inventor tools that we've used in the past. So if you've done any kind of fillet, a fillet is going to require you to do a radial dimension, right? So it's a curve, it's an arc. So back when I did my chamfer here, if I click, right, it's going to allow me to kind of highlight this arc. I can click and I scroll out here and it tells me that the radius that I made it was 0.025. Right? And I can just do a one click and it kind of solidifies it, puts it in place. Right? And again, you're going to want to kind of plan out ahead of time where you're going to put these dimensions. To get general dimensions, it's just, again, like what we did in Inventor. So I'm going to look at a 2-point dimension. So if I go down here and I'm going to look at the far corner of this edge, and I'm going to go to the far corner of this edge, and it tells me that my width of the box was 1.662. And now how to keep going from here, right? You obviously want to get yourself a height. You want to get yourself the thickness maybe, okay? The one thing you want to be careful of is how do you dimension a shell? Because remember, you can't just dimension this thickness. That's not how that part works. So for everybody that used a shell, which should be everybody, what you want to be able to do is create a note for the engineer to know, okay, hey, this thing has a shell to it. All of that surface area is going to be the same thickness. So what you want to do is you want to find a spot somewhere on the drawing that has a good negative space. So typically drawing notes are in between views. They're not usually too far gone from the information that you're looking at. So if I was looking at this, either I would put it here because there isn't really a lot of information, or I could put it right up here. But again, I would try to do this after you do all of your other regular dimensioning. But we're going to create what's called a note. So up at the top, you'll see this letter A, which is our note. And when we do that, it's going to give us what is really a word box or an area to type. And you can put this again in a easy, recognizable spot. It does differ depending on the drawing. So for this example, I'm just going to put it here because there's a nice negative space that I can use. So I'm going to click here and I'm going to zoom in a little bit. And my note is just going to be shell thickness. And when you make a note, you want all of the letters to be capital letters. That's just the way that engineering notes work. So here I'm going to say that the shell thickness, and whatever my shell thickness was, I think I made it 0.025. And I can just check that. Okay, and then that gives me kind of a universal note of that's what the shell thickness is going to be. I actually probably should put in that it's an actual note. So let's do this. So if I click on this again, I can edit it. And we're going to want to make this a little bigger. So I can click and drag that box out. And this would be note. I put a colon there. Let me drag this out a little bit more to get that in one line. There we go. And I can check that. That's a nice note. That works. All right. So if you guys are using a shell, please make that note. It should look similar to that. And obviously your number is going to vary depending on what you use. The other little thing I want to show you has to do with the radius or a fillet. If you used fillets on all of your edges and they were all the same size, you also need to let the engineer know that. So in order to do that, I'm going to double click on my notation here for the dimension, and you're going to see it's actually broken down a little bit easier than Inventor. It tells you that it's a radius, it gives you the size. There's a box here that is allowing you to put a note or a tag onto this dimension. And I've explained this to a few students before. Miss B might have as well, I'm not sure. But we're going to call this a typical dimension. And a typical dimension means that every place that there is a radius, it's going to be this size. That way you don't have to label every radius that you did, because it would all be the same number. So I'm going to put a space, and then I'm going to put the capital letters TYP, which stands for typical. And it's going to come up, and I'll hit enter. And double click on that. There we go. Okay, so just again as a quick review, we talked about a note. We talked about how to insert a note here when you do a radius and how to do standard linear dimensions. You have radial dimensions, you can do a chamfer. If you're looking at a hole, you can be looking at the diameter dimension, remember, because you want the size of it, and then create a note similar like here and tell us how far down it goes. There also is the hole callout, which you can use. So again, it kind of depends on your preference and what design you have. If you have multiple things, guys, please use this week and ask us questions, but good luck and have fun.